So let's start from the first time that we talk about the solution. So you guys already know the definition of solute and solvent already. And now we talk about the solution concentration, which is molarity, morality, mass percent, and mole fraction. For of this solution concentration, you guys have to make sure that you know the definition and you can memorize the formulas, because I can guarantee you that it will come up in the exam. Okay? And then we talk about the solubility. We know the solubility rules, like dissolved light, polar in polar, nonpolar in nonpolar. And today we are going to talk about the factor that affect to the solubility. The first factor that we are talking about is temperature. So when we heat the solution, there are two processes, exothermic and endothermic process. And the way that the temperature or the heat affect to the solubility in each process are different. For exothermic, it's the process that release the heat, right? So the delta H or enthalpy, the total heat in the system, the sign for enthalpy is in negative. But for the endothermic, it's a process that gain the heat. So the sign for enthalpy or delta H is going to be positive. Okay? And when we heat the process, exothermic process is a process that releases the heat. This process doesn't like heat, so the solubility will go down. But for endothermic, it's a process that like heat, they gain the heat, so the solubility for this process will increase. Okay. When we heat the solution or the solvent, we found that there is an evaporation that changes the liquid phase to gas phase. So comparing between pure solvent and solution, you will find that for solution, there is the solute molecule that block the liquid surface over here and make the solution harder to evaporate. But in pure solvent, there is nothing to block around here, so it's easier to evaporate. Okay, that's the summary for evaporation. Pure solvent will evaporate faster than the solution. Okay, and when the liquid phase change to gas phase, you can see the vapor around here over the liquid surface, and we can measure the pressure of this vapor, and we call vapor pressure, and we can calculate that from these two formulas. The first one is P solvent. This is the solvent in the solution, and P solvent equals to the mole fraction of solvent times the vapor pressure of pure solvent. Okay? Or you can calculate the vapor pressure change or delta P of the solution that equals to mole fraction of solute times the vapor pressure of pure solvent. Okay. So normally, in the practice problem, you can see that in the problem you can find the vapor pressure of pure solvent, and it's gonna let you find the vapor pressure for the solvent of the solution or the delta P of the solution. But in reality, in the laboratory, it's hard to measure the vapor pressure. So we can measure other characteristics like boiling point or freezing point. But the boiling point and freezing point of the solution different from the boiling point and freezing point of the pure solvent. So for boiling point, we have the formula that can calculate the boiling point change or difference by calculate by delta TB equals to mkb. Delta TB, that means the boiling point change in degrees Celsius. M, the small m here, is the concentration in molar. And Kb, that is the constant, boiling point constant. The unit is degree Celsius over molar. Okay. And we found that the boiling point of the solution is higher than the boiling point of the pure solvent. And we call this process boiling point elevation. So from this formula, when you calculate delta Tb, you have to add that to the boiling point of the solvent. If your solvent is water, you know the boiling point of water, right? So just add the delta Tb to the boiling point of water, you're gonna get the new boiling point of your solution.